Here we have Lagrange method, and it's similar to Newton method and should give the same value of Newton method, but it's just reformulation of the Newton method in order to avoid the computation of divided differences, which is difficult and confusing of Newton method. So here the first order Lagrange method interpolation y naught times x minus x1 over x naught minus x1 plus x1 times x minus x naught over x1 minus x naught. So this is the formula of Lagrange. Also for second order, it will be y second order y naught times x minus x1 x minus x2 x naught minus x1 x0 or x naught minus x2 plus x1 times these values. I know it's a little bit difficult, but you can memorize it or understand how to write it from your memory easily. So the best way to memorize or how to memorize writing these steps. Now we want to let's start with the first one. First one, y first equal, since it's y first, then we have y naught and y1. Okay, since it's first order, we have only one term, x naught minus x1. In the second order, we have two terms. Okay, so let's back to the first one. Now y1, okay, times term here plus y naught times part here, and then plus y1 times also term here. Okay, now y naught, so here should be start with x naught, and since we here have y1, then here should be start with x1. Okay, we only have x1 and x naught, so here since this is x naught, then this one will be x1, and since here x1, then it will be here x naught. Okay, for the upper part, it always starts with x minus what is written here is repeated here. So here is x1, then here is x1, here is x naught, and here is x naught. Okay, let's repeat the same for the second order. Then we want to define y naught times vector or term here plus y1 plus y2. Okay, since it's second order, then it should be multiplied by two things. Since second order should also multiply by two things and divided by two things. Okay, so regarding the component, we said here y naught, then as we said here, we make here. So here y naught, then the first parenthesis start with x naught, second parenthesis started also with x naught. Then here we have y1, then here it starts with x1 times x1, and here y2 is in x2. Okay, now minus for all. Since okay, here it's x naught, then the remaining is x1 and x2, so one will be x1 and one will be x2. Okay, here we started with x1, so the remaining will be x naught and x2. Here we started with x2, then the remaining will be x0 and x1. Okay, so, okay, now we for the upper part, we always start with x minus, and x minus. For the second part here, it will be similar like the lower part. So x1, x2, x naught, x2, x naught, x1. I think it's easy now to memorize, and you can expect if you are given third order or fourth order, you can now know how you can make them. So let's go for third order. That we need 0 naught, 0 1, 0 y naught, y1, y2 and y3. And since it's third order, then the multiplication will be three terms, okay, for all. Okay, now y naught, then we start with x naught minus x naught minus x naught minus plus x1 y1, so we have x1 minus x1 minus x1 minus. Here we have y2, then we can start with y2 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 I'm sorry, x2 x2 x2, and then y3, then we have x3 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 minus. Okay, now since here we have y, we started with x naught, then we have all other terms rather than x naught. So then we have x1 x2 and x3. Here we have x1, so the remaining will be x naught x2 x3. Here also we started with x2, so x naught x1 x3, and here's x3, then x naught x1 x2. The upper part we start with x for all, x x x x x x, and just we will copy the same x to the upper part. Okay, so this is for third order. For the fourth order, I think now it's much easier. It's look very complicated, but you can do it by yourself. So we can y0, y1, y2, y3, y4, and we have 4 multiple items here. So just I will explain the first one, and just for for saving time, you can find the razor as the other part. So now we y naught, then we should start with x naught times x naught x naught x naught minus minus minus. Then since this x naught, so we have the other part x1 x2 x3 x4. Okay, we shouldn't have x naught, and here x x x, so we just copy the same, then we can repeat the same for other parts. I think now it's very easy to make even fifth or third order, sixth order, seventh order, as you wish, by Lagrange method.